Hello and welcome to the Daily Space. We are interrupting your wait for the launch of a Roscosmos Proton M to bring you some news. I am your host, Dr. Pamela Gay, and I have science. So, the first piece of science that I am bringing you today is there has been a headline floating around on the internet that basically says scientists measured the temperature of a black hole. They didn't actually measure the temperature of a black hole. They measured the temperature of a sonic hole, which is not a thing I knew existed until this press release. So, first thing you need to remember is a black hole is nothing more than something that is gravitationally massive enough that light is going too slow to escape from it. And since nothing can go faster than the speed of light, nothing can escape a black hole. Now, there's lots of different ways to have a something hole. Earth is a people hole. We as individuals are not capable of running, jumping, swimming, otherwise self-locomoting fast enough to get off the surface of the planet. We can use rockets. So the planet's a people hole, but it's not a rocket hole. Now, there are other kinds of waves and things than light waves. And in looking at how waves propagate away from black holes, Stephen Hawking realized that you can have at the edge of a black hole an artificial particle pop into existence that on one side of the event horizon can escape, and on the other side of the event horizon gets sucked back in. And what he theorized, and this hasn't been seen yet, is that black holes are slowly evaporating because energy in the black hole is materializing into these particle-antiparticle on the edges of the event horizon, and one of those two gets to escape, thus carrying mass away from the black hole. Now, most black holes have a sufficiently large event horizon that the rate at which light particles, cosmic microwave background, is falling into the event horizon exceeds the rate at which the black hole is trying to evaporate with Hawking radiation. So the black hole's not actually shrinking. But with really tiny microscopic black holes that have really tiny event horizons, they're actually capable of very quickly and very energetically evaporating. And there was hope that maybe CERN would create one of these microscopic black holes and we'd be able to give Stephen Hawking a Nobel Prize for discussing this. Anyways, that didn't happen. Now, what I didn't know is sound also has the ability to have the sound equivalent of a particle-antiparticle coming into existence. And so what scientists did was they created a sound hole instead of a black hole, a sonic hole, if you will. And they did this by supercooling rubidium gas into an Einstein-Bose condensate, or rather a Bose-Einstein condensate. So this is super cold material that starts to behave in super weird ways. And within this material, sound is incapable of escaping. So sound doesn't hit the edge and keep going, it just stays within the Bose-Einstein condensate. Now, what scientists were able to do was look for the creation of the sound equivalent of the particle-antiparticle to see if sound could escape in this evaporative kind of way that is parallel to Hawking radiation. And it does. And what's also cool is one of the predictions of Stephen Hawking was the temperature, the energy level of the Hawking radiation is directly correlated to the size of a black hole. So you end up with hotter evaporative materials. When you have a bigger black hole, you have colder evaporation when you have a smaller. And it's a distribution of energies in the particles. It's thermal radiation, essentially. And what they found is the sound equivalent with the sonic black hole is thermal radiation sound equivalent, and it matched the predictions. So while we haven't seen Hawking radiation, we've seen the moral equivalent in the realm of sound. And there's a lot of black holes, a lot of headlines about black hole temperatures being measured today, and it's actually a sound hole, a sonic black hole, pick how you want to call it. It's still cool and weird. And I wonder how people think of this stuff. I am not creative enough to be that kind of a scientist, and I'm really glad there are people out there that come up with these amazing ideas. Anyways, it's cool. So, on to our second story of the day. This is a hyper-colorized picture of Pluto. If you looked at Pluto with your eyeballs, it doesn't look like this. It's much more boring. But this is the cool, hyper-colored version with all the colors stretched that was part of the press release. And scientists studying Pluto have been looking at its composition variations across the surface, have been trying to figure out its thermodynamics. Last week, we presented a story about how hydrates, special kinds of minerals that trap gas inside of them within the surface layers of Pluto, are capable of creating an insulation barrier that allows Pluto to have a subsurface sea. And today we have a new press release that talks about how that subsurface sea, just like the magma here on Earth, has the ability to escape. Like we have volcanoes, Pluto has cryovolcanoes, ice volcanoes. And by looking at the chemistry at the surface of Pluto, they now believe that there may be organic materials that are escaping through these volcanic eruptions. So there are waters with organic molecules within the waters that are getting ejected out the surface of Pluto. Now, the cool thing about this is it gives us the potential to get samples of what that subsurface sea is like without having to dig down and get it, without having to potentially risk polluting that ocean. And if there's organics and it's warm enough, that means there's also the potential for subsurface life on Pluto. Now, this isn't to say that there is subsurface life, that there must be subsurface life. It's just there's the potential. And it's amazing how in the past few years, or a couple of decades at this point, I'm aging myself, we've gone from believing that life can only exist in this narrow band near the sun where water is capable of existing at the surface of a planet as water, liquid water, to now understanding that there are liquids in a myriad of other places in our solar system, and that the correct place to look for life might actually be deep beneath the surface of an icy world. Science tells us the unexpected and is far more creative than we ever will be. Okay, now, for the past several days, it's now been a week, I have been promoting Bennu Mappers, your place to go and map rocks, map boulders, map craters, and you've been doing it. Over 1,500 of you so far have helped. And this is awesome. We need more of you. If you have not yet mapped, it is time to get involved. And what I'm pleased to be able to share today is I did a data visualization of a completely randomly selected pair of images. This is the first randomly selected image. And when you guys get this image in your browser, it's actually divided up into 9 different pieces. And you can start to see 2 of the corners based on there was someone here who marked more rocks than the person who did the middle part up here. So this image gets broken out into 9 different pieces. Each of those pieces goes to 15 different people. I then pulled all the data from all those humans out of our database and plotted it. And it works. you guys are getting this right. You're doing it. And there's occasional problems. There is one soul who was outlining the boulders. You don't need to outline the boulders. Just draw a line across their diagonal. But that's okay. We can find that one person and take care of things. But what I'm really loving is looking at these really elongated rocks. You can see just how similar everyone's marks are on these rocks. You can see that some of these rocks that are weirder shaped, there's a diversity of lines. This one up here is kind of round, and you can see that no one quite could figure out where the longest axis was, but there's a hint that this way is wider than this way. This is exactly what we were hoping to see. Now, this isn't the only image I pulled. I also pulled this one. Again, 9 images combined into this one mosaic. Now here you can see there are some of you who, oh my God, you're marking grains of dust. I love you. You are fabulous. You are putting too much time into each image. You will never finish. Mark fewer grains of dust. This is your reminder when you are marking things in our mapping tool. Only mark the things that are half a blue dot across or bigger. This image here was marked by one of the team scientists. This is perfect. This is exactly what you should be aiming to do. So you guys are doing awesome. We are going to have more than 4,000 images altogether to mark. You have already made it through almost 800 of them. We have until July 10th. Keep going. We're doing this. Your data is good. I am so proud, so pleased with all of you. And I'm going to be sharing all of these successful images over on Discord. And I'm going to be sending a newsletter out at some point today. So thank you. You're doing science. I am happy. I'm very happy. Okay. I am going to find my chat and bring it closer to where I can see it because it's way on the other side of the screen. And we're going to switch over to Annie shortly. I need to see when she's ready. So Rukato Presents is asking, do you see when craters are marked? So I have to admit, I forgot to visualize craters when I put this image together. So I'm going to be adding the crater visualization to my software later today. I know there's craters in there because I've marked some of them. I just forgot to visualize them. Okay. Yeah, it's really cool to see how well everything is working. I'm so proud of all of you. Okay, scrolling up to answer questions. I'm not seeing questions. Nope, no questions. That is... Oh, wait, no, I'm logged in as me. Hold on. I need to find the chat that isn't Star Strider, but is CosmoQuest. And I have no history. Ah, okay. I'm going to scroll through looking for CosmoQuest. So Larry Weird and Proud is asking, what is anti-sound? So they didn't explain that in the press release, and I have no idea. I think the way to think of it is not so much anti-sound as you have two sound waves that are propagating in the opposite direction and are completely out of sync, so that the up amplitude on one wave is the down amplitude on the other, and they equal out to no sound wave. Yeah. Scrolling. Eddie and Stella are being very cute today. It is true. It is true. Eddie is slightly off camera. Eddie does not want to be on camera today. There. Now you can see the Doge face. Okay, so Annie, whenever you are ready to take the stream back, we can do a handoff. And until then, I'm going to pause and do a station identification. We are brought to you by the Planetary Science Institute, working in collaboration with Youngstown State University. Thank you, Veronica. And we are brought to you by you. If you like what you see, please consider giving us a sub, being our Patreon over on patreon.org/CosmoQuestX. And if you can't afford to donate, that's okay. We still love you. Do science and spread the word. And I'm going to hand everything over to Annie now, so stay tuned. The stream will be right back with a rocket launch by Roscosmos of a Proton M. I believe this is coming to you from Bacanor. Bye-bye.